It's a really good thing we have an immune system, or we wouldn't make it far past the stage of sitting in a high chair as a child. Let's take a look at the adaptive or specific immune system of the body. The first process we'll look at is the complement system. This was a way the body quickly responded to bacteria. The classical pathway was a rapid activation because of this C1 protein that binded to antibodies that were already present. This process allowed for opsonization, which is the coating of objects with antibodies to enhance phagocytosis. Many proteins work together through this process to further create a pore in the bacterial cell to eventually lead to its death. This process often triggers histamine release, causing inflammation. This process reduces the spread of pathogens. Cytokines are released to attract neutrophils and macrophages to speed up the cleaning of the dead bacterial cell. The alternative process has the same goal, but antibodies aren't present right away for this process to begin. The next process we can look at is the class 1 MHC process, represented here by this Pac-Man. This is a cell-mediated process involving an actual infected cell. The cell becomes infected by a foreign particle, which is usually a hapten or partial antigen that does not stimulate antibody production in the final product. However, this foreign invader is broken down and presented here as an epitope. A CD8 T cell comes along and the T cell receptor recognizes what's going on. This directly stimulates cytotic T cells, which are phagocytotic cells that will destroy the infected cell and warn the body of what infection is coming around to different cells. Memory T cells are also seen to be created out of this process to prepare the body for future problems. Now, the class 2 MHC is also very specific and very important. Cells actually come along and eat a foreign particle, and they break them down into the antigen and proceed to present it as an epitope to a CD4 marker here, which then activates cytotoxic T cells, again phagocytotic cells, as well as what are really important, helper T cells. B cells that have been exposed to a complete antigen, which has 2 binding sites for antibodies, have become sensitized and are waiting now for activation. Helper T cells activated by the class 2 response have this big responsibility now to activate the B cells. B cells then become differentiated into these plasma cells, who then ultimately secrete what we know as antibodies to fight the antigen. Out of this process, memory B and T cells are created to really prepare the body for future infections, so the body will be prepared when it is faced with this. Now, once an antibody is exposed to an antigen, has a few ways of dealing with the invader. The antibodies themselves can block the antigen binding site so no reaction occurs at all, which is very common, known as neutralization. Antibodies can also create the formation of a soluble complex known as precipitation, and the precipitant actually settles outside the cell. I have this modeled here by oil and water, so you can see that this insoluble solution is, the oil doesn't settle inside, it settles on top of the water there. And then also the final way an antibody reacts is by agglutination. Most people see the agglutination test performed in blood typing when an unknown antigen is mixed with a known antibody. Agglutination is where the cells are bundled up and formed in a ball so that they can all be caught together. They clump up, and the reaction is usually seen to be something like this when you do the blood typing test. So this is all about our adaptive immune system, And that is all I have for you. Thanks.